Our next example looks easy, and that's always something we need to watch out for. I mean, sometimes it is easy, but other times it's not. When we take a look at this, there are a lot of problems. This is a surprisingly hard question. So this here has got a lot of tricks to it. To start with, there is no moles or grams. So this is probably going to be combined at some point. So let's take a look at some of our tricks. There's actually 3 tricks here. Trick number 1 is the grade killer, right there. Celsius is the grade killer, because you think Celsius will work, but it will not. You need to change this to Kelvin. So no Celsius, you need to make it into Kelvin. So I'm going to take my 100 Celsius, and all I have to do is add 273, and that'll give me my Kelvin, my 373 Kelvin. So this here, this is the temperature I'm going to use. Okay, now it says it starts at STP and it's heated to this. So this here is our T2. So it's good to know that that's what we have. So that's trick number 1. Trick number 2 is this term STP. STP means our temperature is going to be 273 K and our pressure is 1 atm. So there are 2 numbers here that are hidden. If you don't know what you're looking for, you would miss it. So when most people see this problem, they only see 1 number, but there's actually 3 because STP translates into those 2 numbers. This, by the way, is our T1 and our P1. So as you can see here, we very much have our P1 V1 over T1 equals P2 V2 over T2. We have our T2, we have our T1, we have our P1, and it's looking for our new pressure, so it's looking for P2. So we have to go, okay, well, what about volume? As you can see, volume is not mentioned at all. I mean, that's a problem, right? I mean, we need volume. I mean, there's volume here and volume here, but, you know, there's no volume in the question. So what do? Well, what you do is you triple check it. You check it 3 times. You read the problem again. If a gas at STP is heated 100 degrees Celsius, what is the new pressure? Again, no mention of volume. You break it down, no mention of volume, and then you take a real good look at it, and if you can say, hey, there's still no volume, then you can assume volume is constant. So after the triple check, then you can treat it as a constant, meaning it just does not matter to the problem, so we can cancel it. But you really got to give a good long look at that before you make that jump. Otherwise, you could goof, and you don't want to goof. So let's plug in our numbers. We've got our P1 is 1 atm. Our T1 is 273 kelvins. We do not know what P2 is. That's what we're looking for. And our temperature is 373 kelvins, which, if you recall, we got from converting to Celsius. We do our unit trick. Atmosphere over Kelvin equals, blank over Kelvin. It means our missing unit is going to be atmosphere. So now we don't have to worry about units. And all we have to do then is we have to multiply both sides by our 373. Times 373, we'll cancel this out, but we have to times by 373 on that side as well. So I've got 1 by 273 times 373 equals, and that's going to give me my answer, which I will set to 3 sig digs based on the problem, which means 1.37 atmospheres is my final answer. And so that is dealing with the combined law.